Maggie. Thank you for inviting me. Yeah, stimulation needs after a heavy lunch. Uh, Otherwise, most of the audience fall asleep, right? so, so today I will I will not talk about this disruptive tidal waves. Rather, the concepts that you use gradually to make a student a proper physicist so that they can study those high-level physics problems. They can tackle that. I will use pretty blasphemous thing today here, blasphemy when I come to KITP, like chalk and board is the norm. I will use some technology. So that's blasphemy at KITP. So please, Lars and David, please forgive me for that blasphemous thing. So what I will do is I will make the talk interactive, and I will request you to use your cell phone. So using your cell phone, you can answer some of my questions, and then we'll discuss that back and forth. So to go to that web page, please scan this QR code. And my talk would be more on knowing physics laws versus understanding physics laws. This is the statement we often hear from the students. I know that thing, but I don't really understand it. And I'm sure many of the physics teachers have also heard this thing from the students. And so please go to that web page, and I will wait for a few seconds more. You can take your cell phone and go to that web page, and then we'll start with this question that these two guys are on a cliff. One is just dropping this ball, one is throwing this ball, and then the question is, which ball will have greater acceleration? So you can see the question on your cell phone. If you don't get it, you go to www.menti.com and use this code. This question will appear on your phone. You got it? Okay, good. So I can see 7 of the audiences have answered this question. So, and after we get most of the answers, we'll after 27 seconds, 20 seconds, we'll see the distribution of the whole class or the whole audience. So this, you can use these techniques in your class to get a formative assessment in real time. And 7 more seconds. Who is holding their breath? Okay, so you see, this is where it starts to deviate, right? So both the balls, when they are thrown downwards, it's the initial condition, initial velocity that is changing, but the acceleration is under the influence of gravity. So the gravitational acceleration is the only acceleration, right? Okay, so this is the warm-up question. Let us go to the next one. So the next question is, please look at your cell phone screen. It says that Steph steadily reels in a fish which is going upward at a constant speed. And which one of these answers is the correct answer? Is the force on the upward force on the fish is greater than the downward force? Or they are the same, or the downward force is greater? You still have 30 more seconds, and you are allowed to talk to your peers. You are not alone in this physics world. So the fish is going up at a constant speed. 13 only. We need more participation. And this is completely anonymous. You see, nobody would know. Wonderful. So this is much better. So 44 of the participants have done this. This is much better. The answer. So obviously, from Newton's laws, the acceleration is 0 as the fish is moving upward at a constant speed. So it says that the tension upward and the downward gravitational force have to be equal. But the students often make a mistake in this problem. Okay, so next question. Bianca is sitting up, sorry. What's that? No, not that one. Yes, yeah. So Bianca is sitting on a flat bed of a pickup truck. The truck is accelerating to the right. In what direction does the friction force act on Bianca? So remember, this is Bianca. So let me go to the next slide and give you the question. This is delivered on your cell phone now. Okay. Oh, I'm sorry. So this is the question. Okay. Okay. So raise your hand who thinks it's A. Okay, 50% of the room. B. Who thinks B is the answer? No one? Or C, there is no friction? Or D, more information is needed to answer this question? Okay, so now let's go to the blackboard and and see what is the problem. So the problem is that there is a truck here, right? And there is an object here. So as Kate said, or somebody who said that for a physicist everything is in a circular cow, right? Spherical cow. So no matter what, somebody is sitting on the truck bed, and as the truck is accelerating in this direction, this object is also accelerating in this direction, right? So you use Newton's second law that net force on the object is mass times acceleration. And that tells you that there is only one force acting on this object which is creating the acceleration. That has to be friction, right? Without friction, except friction, there is no other force on Bianca which will make Bianca accelerating in that direction. And trust me, this question is very, very confusing for the students, because the way physics books are written, they say that the friction is a force which opposes motion. Which motion, right? So the way we teach this, we explain this question, even if you give this answer, many students don't believe it. Then ask them, what if this truck bed is made very slippery? The moment the truck starts to accelerate, that's the direction of the potential motion. So friction is opposing that potential motion, so it has to be in the forward direction, right? So friction is a great way to teach the students. So let's do this problem, and I will hope that it will appear on your cell phone this time. Yes. So a car is driving up a hill at a constant speed. Which arrow shows the direction of frictional force on the car's tires?
Excuse me.
Yes.
I have a question.
Sure.
On your last slide, when you had stated that it was the friction on Beyonce and what she was feeling. When you gave your explanation, I didn't hear her name in there. So how do I know you're talking about her, not the truck?
Oh, so the question, it was like, what was the direction of friction on Bianca?
Yes.
Yeah. So here, this is Bianca sitting here, and Bianca is accelerating with the truck, right? If the truck is accelerating, that is also Bianca's acceleration. And the force, net force on Bianca has to be that mass of Bianca times acceleration of Bianca. And where from this net force coming? There could be only one area from where the friction can come, and that is giving the net force. Okay? Yeah. Okay. So see, this is what happens. That now we are coming to 50-50 range, right? And this is what we want to discuss, and we want to stress on, that this is where knowing Newton's laws and understanding means applying it to real life phenomena, we deviate. And then students, they start to make the equations or jargons as shield, right? And they try to hide behind those shields, because eventually physics is to understand nature and understand how nature works. So if it becomes only mathematical equations, then we start to lose the connection between the physics problem and the mathematical solution. So let us go back and check the problem. The problem here was, there was a car here, the exact same problem as before. The car was here, and the car is moving at a constant speed. So v is equal to constant, right? So what does that mean? What is the acceleration of the car? 0. So acceleration of the car in that direction is 0. A is equal to 0 in this direction. How can, so if the acceleration is 0, that means the net force on the car is 0. Now let us check what are the forces acting on the car. Obviously, there is a gravitational component of the one component here, right? mg sine theta. We all teach in high school that mg sine theta is in that direction. So to make it 0, the net force 0, there has to be another force in that direction. And that's the friction force. That's only friction force can be applied in that direction to make the force, net force 0. So this is contrary to our belief that friction is always opposing the motion. Which motion we have to always ask, right? Again, what is the other physics explanation? If we make it slippery, what direction the car will go? It will slip in the downward direction. So friction is preventing that slipping. So friction is upward, right? So this is the way we think that if we always connect mathematics and the laws with real life phenomena, then it becomes easier for the students. So let me go to the next question. This is also a friction question, but so far we have talked about motion in a linear trajectory. Now we are talking about motion in a nonlinear trajectory. Here, this teeny alien is on a turntable, and it is rotating at a constant speed. It's rotating without slipping. So the question is, what is the direction of friction on it? Use the very similar argument that I used in the previous two examples. There's a big distribution still. So we have to hammer it again and again and again, right? So this shows that even if we are teaching it for a long time, when it comes to applying the principles, see this is a uniform circular motion. This object is moving in that direction. So what is when an object is moving in a uniform circular motion, what is the direction of acceleration? Everyone knows. Centripetal, right? So that's the acceleration, direction of acceleration. Who is providing this acceleration? Acceleration means there is a force. Who is providing this force? Only friction can provide that force, right? So that's the direction of friction. It has to be. So this is one trick we always tell the students. At first check the direction of acceleration, then come to the conclusion. Without doing that, you are prone to make mistakes. And mistakes are everywhere, not only for like the high school students or undergrad students. We make mistakes too, because if we don't start to intervene or check the problem from proper perspective. Another nonlinear problem.
Excuse me, sir. Can I ask you a question?
Yes, yeah.
So you're saying that the method that we're doing is saying that general definition that friction is the force is opposite to motion is incorrect, and therefore we need to do step A, look acceleration, step
Exactly.
B.
Yeah.
So we should be teaching, you're saying, of asking critical questions. One,
Right.
2, 3.
Exactly. Absolutely.
The 1, 2, 3, will you be able to give us?
1, 2, 3 is start with Newton's laws.
That works too. Okay.
Yeah.
If you change, the way I teach it is I change the word motion. I tell them cross out the word motion and replace it with slipping. Friction opposes slipping of two surfaces past each other. Doesn't matter which way you're trying to go.
So that opposing motion is still good, but you have to find out which is opposing from like what is the object we are talking about. Unless and until we define that thing properly, you are bound to make mistakes, right? So this is another problem. I have given you much more time this time, right? So let's go to the question. So this is, oops, yeah, here you go. A truck is driving at a constant speed along a curvy road. The heavy line on the right shows the truck's path as shown from the above. So this is the bird's eye view. Which arrow describes the direction of friction? So I'm bringing friction more and more just to highlight this point that we are doing it again and again and again. And we know how it works, right? But still, so if we as adults are having difficulty, we are trained, but still we are having difficulty in processing it. So imagine the students. We have to hammer again and again and again. Otherwise, they will learn a bunch of equations, but they will not learn how to apply in real life situation. Connecting nature. And that's the end goal, right? Physics' goal is to understand nature and connect nature. Okay, so this was the problem. That the path of the truck is this. It does not matter in whether the truck is going this way or that way. The first thing to understand that any nonlinear motion means there is an acceleration, right? Any nonlinear motion means acceleration. So when the truck is here, it's part of that, you may think that this is part of that circular motion, and the acceleration is in that direction without giving any specific information, right? Acceleration has to be in that direction. That is bringing the car, pulling the car in that direction. That's why it is bending its track, right? So that's the direction of acceleration. And that acceleration can come only from the friction between the tire and the road. And that friction, the same friction, becomes in this direction when it is here, right? So it's an inanimate force and it's changing its direction. And students find it very difficult that I'm not pulling it or pushing it. How can it change the direction? It's the law of nature. That's how Newton's second law works, right? So this is, even if Newton's laws they sound like very trivial now, when you say general theory of relativity, GTR, that does not sound trivial. But Newton's laws sound very trivial. It's not. It's not trivial. It's groundbreaking. We are forgetting that thing, that it is groundbreaking. And Aristotle and those big shots, they made mistakes, right? So connecting the motion and the force. So we are going back to that same point, that it's not the motion. We always try to think in terms of motion or velocity. It's the acceleration. We have to always check the acceleration. Very good. So let us go to the next one. So we started from motion. We are now going into energy. So a heavy truck, a light truck, and a dog on a skateboard rolling down different these steep hills. And the question is, which one will have the greater speed? Oh, sorry. Sorry, I forgot to put that image in there. My apologies. Yes, so. So let me give you the answer, and most likely all of you have gotten the answer. So by now, that there are different slopes of the same height, but it does not matter so long as you are equating the potential energy to kinetic energy, right? And you see it depends on the height only, and it would be mgh is equal to half mv square, or that means v is equal to square root of 2gh. And for all the cars, it would be the same speed. Yeah, it's a standard problem, and still there are some deviation. Okay. 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 So that was not your fault. That was because the image was not there. I accept that. Okay. So the next problem: two cars with different masses are sliding down to inclined hills, identical hills of the same height. Which one will have the greater speed? No friction, yeah. No friction, exactly, no friction. Sliding down without friction. So just before Christmas, they're delivering one massive gift, a small gift.
Yeah, person A is in debt more, no, B's in debt.
Okay, so that's good. But see, the answer is written here, and we see that every time in class. Even if you write the answer, there is no mass in here. It's in front of your eyes, right? So these are the practical problems, and often we don't realize, unless and until you do this formative assessment, real-time feedback, how much student population is getting your concept. So this is very, very important to do this formative assessment, because otherwise what happens, a large portion of the student population, they're getting behind. So they're not catching up, and eventually, and you are going further and further. So it's scaffolding process, right? Learning is a scaffolding process, and if they fall behind, eventually there are no other option for them but to cheat. So this is another question. This is on moving on to EM. So this is Bianca again, I believe. And she has a negatively charged rod, and this is a metal ball, neutral metal ball. And she is bringing that negatively charged rod. So what will happen? The ball will start to roll towards her. It will repel the ball, or nothing will happen. You can talk, you can discuss. I see. Yeah. So, and we teach that in class, right? We teach the induction, how you do inductive charge transfer. So if I frame the question more like this, then I'm sure more people would get the correct answer. The rod pulls the metal's electrons closer to the rod and repels the ball because it will become an induced dipole, isn't it? This is exactly what happens when you rub a balloon on your sweater and bring it close to the wall. The wall attracts it because it induces dipole of the wall molecules, right? So this was the question. I have reframed the question, the same question. So I'm not giving it to you. Yes, yeah. No, the correct answer would be the negatively rod pulls the metal's electrons. The rod pushes the metal's electrons away from the rod and attracts the ball. So this would be the correct answer, right?
Was it a metal ball in the first?
Yeah, yeah. Metal ball, yeah.
I'm pretty sure I chose A, and I'm pretty sure A was in track last time I looked.
Oh, okay. Yeah, could be, okay. Yeah, maybe, yeah. Okay. This is correct. Okay. So, bring the guillotine. Okay. Now, coming to curiosity, how can you apply these principles in curiosity-driven research? Because research is always curiosity-driven, right? So, this is where Gecko comes. How does a gecko stick to a wall or a ceiling? Using hooks, sticky glues, suction. Let us see what everybody thinks. Using hooks, sticky glues, suction. Nobody knows? It's actually the Berkeley group. They figured out that the geckos stick to the wall or ceiling by van der Waals force, right? So none of them are correct. Yeah. So this is a trick question. So none of them is correct. So this is how geckos have hairy toes and they stick to the other surface by using van der Waals force. But the question could be like, how come two neutral atoms or molecules, they stick together, right? So van der Waals force, when this is a short range force, when they come close to each other. So how do two neutral atoms or molecules stick together? So here comes, I'm not giving a question here, so let me explain it quickly within 1 minute. So in classical Bohr model, you know this is the planet model and the quantum mechanics model, where this is the probability distribution. This is exactly the same phenomena that in quantum model also, the charge distribution or probability of finding the electron is not exactly the same all the time. If you take a snapshot, at some point of time, it is the charge density of electron is higher here than the other. Probability of finding the electron is higher here than the other places. So it is making it effectively a dipole. And eventually, when two dipoles come close to each other, when one dipole comes close to another neutral atom or molecule, it induces a dipole, and then they stick together, right? So we can use these very simple principles to explain a lot of new cutting-edge innovations and things, right? So that was all about, I mean, we have created 200 concept clicker questions like that for formative assessment, and I'll be happy to share with you these questions. And let me acknowledge the cartoonist, Larry Gornick, who has drawn all the questions. Thank you, David and Maggie, for inviting me. Lisa is always phenomenal in encouraging me. Lars, KITP logo is here. Thank you. And my funding agencies, without whom I couldn't do anything, any of that. Thank you very much.
All right, that was fantastic. We can take maybe one quick question while we are swapping over to our next speaker, if anyone has a burning question for Kausik.
Yes.
How do we access your library of 200 questions?
That is, I'm trying to figure out what would be the best option. At this moment, if you email me, I'll send you all the questions. Those are free to use. I'm not publishing a book or anything. This is like, I would like it to be used by the teachers. And hopefully we can create a teacher's training program also, or workshop also, where we can discuss all these questions and answers, and everybody would be benefited by that, right? I know less than 34% of the high school physics teachers are actually trained in physics. So, and this is not their fault, not the students' fault. So we need to provide this type of interaction, this type of, we create some type of workshop. So I'm looking forward to it. Yes. Thank you. Thank you very much.
All right.
Yes.